so that I don't miss anything. Trying to think. I was just looking at our schedule. So we have our project coming up, and I will get that uploaded today. And so if you want to ask questions, more specific questions about it, probably hold those off until Wednesday, because then you'll be able to look at it and see if you have any questions that need clarified. It should be pretty self-explanatory. You will need to be able to do linear regression, so make sure that you can do that either in Desmos or on a graphing calculator. That is the wrong one. Not gonna work. There we go. Okay, and then that is going to be due. The original due date was the 18th, but I'm going to push that back to the 25th. So you'll have until October 25th for the project. I don't want to rush you in a week if you have other things that have to be done this week. You know, you might have tests, and I know you have assignments for me. You might have tests or papers or whatever for other classes plus work. So it'll be due on the 25th instead of the 18th. And that shouldn't really matter in terms of our schedule and how that goes anyway. So that just gives you a little bit more time for that. And then the material from last week and this week that you may or may not have questions on will be dealing with polynomial functions and then factoring. So that's what we'll be working on, hopefully mostly through your questions that you have on things that you've been doing lately. So go ahead and shoot with any questions you might have. So let's do a quick poll in. Okay, which sections are you working on right now, Corin? Are you working in the chapter 5 sections, the polynomials, adding and subtracting? Okay. All right, I think what we'll do, because I don't want us to build up too many questions for later in the week, so I'm going to sort of overview a few different things today. And I think I'll be able to overview adding, subtracting, multiplying, and dividing polynomial functions. So that'll take us through most of everything that you guys should have to do in all of the chapter 5 materials. There is some other stuff on exponents and scientific notation. And if I get a chance, we'll get to some of that today as well, so that you've got some background for that section. That's section 5.2, so it comes in the middle of all that. But I think we'll do the adding, subtracting, multiplying, and dividing first, because they all kind of flow together nicely. And then we'll step back and look at scientific notation and negative exponents. Sound good? All right, so I'm going to share whiteboard again, and then I'll just work like a couple problems per page and we should be good, I think. So I'm going to escape that so I can see how everything is showing. Okay, so the next actually 2 chapters for the most part deal with what we call, oops, we're using a green that's not all that visible, so I'm going to switch that back to black. And here you're going to be dealing with polynomial functions. So these are just functions that are built up of lots of terms. And you guys probably remember working with these, although you may or may not remember what the name polynomial means. So poly usually means many, and nomial comes from names. Mathematically, we think of this as many terms, although many is used very loosely. So in polynomial functions, there are functions that we call, monomials, and that means one term. So that would be something like 5x squared. That's a monomial. It's one term. It has degree 2. The degree is just the highest power on any one term. And it has coefficient, that's the numerical number in front of the expression. So on that one, the coefficient is 5. So they ask you for the degree of a term or for the coefficient. That's what they're looking at. A binomial has, just like bifocals, 2 terms. So something like 3x plus 4yz. That's a binomial. That binomial has 3 different variables in it. So the degree on an expression that has more than one variable is a little trickier to figure out. You have to add up all the powers from each term. So in other words, that first term is degree 1 because it just has one factor of a variable. The second term is degree 2 because it has y to the first power, z to the first power. So 2 factors of variables in that one term. And that means the whole thing is degree 2 because we always take the largest of the degrees from any one term. And then we stop naming them after trinomial, but trinomial means 3 terms. We could keep going, but it's a little bit funky sounding. Quadrinomial, I'm not even sure what we would call it. So trinomial means 3 terms, something like x squared plus 2x plus 5. So that's sort of some basic language of polynomials. And then what we want to do is deal with all the operations. Adding and subtracting, I'm going to claim that you guys have probably done before. So let's sort of add a page here. Essentially, you're going to combine like terms. And the hardest part about this is making sure that you write everything down correctly. So it might even be more difficult just in Alta because you have to mess with making sure that you type your exponents correctly and that you get your signs correct. So be really careful there. But you probably would get a problem like 2x squared minus 3x plus 7 plus 8x squared minus 10x minus 9. And so to do this problem, we're just going to look for like terms. Why don't you guys go ahead and try that? And when you think you have the answer, go ahead and, I'm going to say go ahead and type it in the text, in the chat. And we'll see what you came up with. And while you guys do that, I'm going to go grab some problems from Alta so that I get them around the same level of difficulty that you're getting in homework. Okay, so it looks like 1, 2, 3, 4, at least 5 of you have the same answer. And you came up with 10x squared minus 13x minus 2. And that looks good. Let's try a similar problem. So red line to separate them. I'm going to keep the first term the same, first expression the same, not just the first term. And then I'm going to change this to minus 8x squared minus 10x minus 9. So let's go ahead and try that one and see what we come up with. And again, let's go ahead and type that in the chat when you think you've got the answer. Okay, so it looks like Mateo and Megan agree, but you both goofed up. Let's see. Dakota disagrees and Dakota is correct. So how did Dakota, and Kellen agrees with Dakota? Very good. Those are actually really good wrong answers, Megan and Mateo. And by that, they allow me, what I mean is that they allow me to show you, yep, that you do need to sort of distribute that negative sign. When we say we're subtracting the entire expression. Some students like to think of it as multiplying that whole thing by a -1. And then if I distribute that -1, I get minus 8x squared plus 10x plus 9. So I've got a minus 6x squared, which everyone had, but now I have plus 7x plus 16. So that's just something to sort of watch out for. I want to do one more on this page, and then we might do a couple more, but I think we're probably good here. The adding and subtracting is pretty straightforward. Let's try this one. This showed up in my Newton when I opened it up. This was actually the first, oops, it wasn't an X. This was the first question I got. It said to simplify 6p to the fourth plus 8q to the fourth. I wrote those numbers backward, but it doesn't matter. So what do you think you have for the answer to that one? Do we have any like terms? Yes, it's already simplified. That's correct, Jenna. So if we were doing this on pencil and paper, you'd probably write to me that it's already simplified or that it can't be simplified or something like that, and that would be fine. They want you to just type it back in. So in Alta, make sure that you don't skip it. Just type in the same as you had for the original answer, and then that will be your answer. All right, then let's try another one. This one is from their wording exactly. So they gave you functions. So they did some of these in function notation. So they said, well, let's let f of x equal negative 5x cubed minus 4x squared plus 8x. And they let g of x equal negative 4x squared plus 8. And they want you to find two things. They want you to find f minus g of x and f minus g of negative 2. So we need to know what this notation means. So first things first, and this works for every operation. So this works for addition, subtraction, multiplication, and division. When they say find f minus g, they're just saying subtract the two functions. So this just says f of x minus g of x. It's sort of their fancy way of shorthanding the subtraction. That means that for the first part of this, I'm going to put a little border here so we don't run into that other side. For the first part of this, we're going to subtract. We're going to do f of x minus 5x cubed minus 4x squared plus 8x. And we're going to subtract g of x minus 4x squared plus 8. It's not very dark. And then again, like last problem, we'll have to distribute our minus signs since this is a subtraction problem. So plus 4x squared and minus 8. And I come up with minus 5x cubed plus 8x minus 8. Do you guys agree with me on that part of that one? Okay, looks good. So the second part of this, we can actually do two different ways. So when you see a number after a function, or in this case, after a difference of functions, this says you're going to subtract the functions, but then you're going to substitute x equals -2 in that difference. So since we already did the work, we can go over here and use that work. -5 times -2 cubed plus 8 times -2 minus 8. And of course, we can check this on a calculator to make sure we get the right answer. Let's see, -2 cubed is -2 times -2 times -2. So that's -8 minus 16 minus 8. So that looks like 40 minus 16 minus 8. And I think if my subtraction is correct, I get 16. You guys double check my work. And then I'm going to show you a different way to do this, which is kind of nice because you can then check it two ways for yourself when you don't have another human there to check your answer against. So 16 is what we get for f minus g of -2. Super, super important. That means plug in the -2. It does not mean multiply by -2. So the notation is really important that we understand what that means. It says subtract the functions and then plug in -2. But it turns out that you can do those operations in the opposite order if you want. So what we could have done for this second part is we could have said, you know what? I want to figure out what f of -2 is. And I'm going to do -5 times -2 cubed minus 4 times -2 squared plus 8 times -2. And let's see, I get -5 times -8 minus 4 times 4 minus 16. So I get 40 minus 16 minus 16 is 8. Then I would compute g of -2. And I get -4 times -2 squared plus 8, which is -4 times something's wrong. Oh, plus 8 times 7. All right, well, let's just keep going. Maybe I'm seeing something backward. Let's see, -4 times 4 plus 8. Something is amiss. Oh no, it's good. I was just thinking wrong for a minute. Okay, I get -8. I was thinking we were adding these two functions, but we were subtracting them. So if we subtract them, we should get the same answer. 8 minus -8 is the same as 8 plus 8, and that is 16. So you can plug in the number to the original functions and then subtract if you wish. In this case, we needed to do both anyway because they wanted this answer first and then this answer second. So just a little note on that. You can do those both ways. And then they give you some problems where they just ask you some questions about the polynomials and whether they're monomials or binomials or trinomials or something else. So those are pretty straightforward. You can count the number of terms. Remember, you'll know the number of terms by things that are added or subtracted. So first expression that we have here, this monomial, one term, nothing added or subtracted to it, so a single term expression, that's a monomial. Two things added together, a binomial. Three things added. They could also be subtracted, but not multiplied. So be careful, because if you have something like, let's see, we'll just do something funky. 6x squared plus 2x times 3y squared over 7. How many terms does that have? 1, 2, 3, or 4? One of those answers is correct. Mateo says 3, Jenna says 4. This actually only has 2 terms. And it's 2 terms because if I were to simplify a little bit, I'd have 6x squared, so there's one term. And then I see my plus sign. And then I have 6xy squared over 7. And that's all one term. So terms are expressions that are added or subtracted from one another. So this only has 2 terms, and it's a binomial. I'm glad I went back and showed you that one. Do you see that now, Jenna and Mateo? So we're looking at a separation with a plus or a minus to give us additional terms. All right, so degree, number of terms we looked at. We looked at addition, we looked at subtraction. Let's go ahead and move on to multiplication. And this really all gets down to the distributive property. Even on the more complicated problems, we're really just extending the distributive property. So I'm going to remind you of that. I'm going to kind of break this down into cases. If we have a monomial, remember that meant one term, times another monomial. So something like 2x squared, it's not, Thanks, Mateo. Okay, have a good day. Let's do 2x squared times negative 3x to the 5th power. And this will actually get us into some of that exponent stuff while we're here, so that'll be good. All right, so how do we multiply monomials? Well, we just nicely multiply together our coefficients. So I'm going to take my 2 times my negative 3 and get negative 6. And then I'm going to multiply my variable expressions by adding exponents. So x squared times x to the 5th is x to the 7th power, x to the 7th power. It's kind of funky for me. And that's it. So a quick reminder in there, we did use a property of exponents, and the property of exponents that we used was the property that said if you had x to a power times x to another power, I'm going to say x to the m times x to the n, we could simplify by adding those exponents and keeping the base, x to the m plus n. Now, if we want to sort of step that up a bit, we might have a monomial times a polynomial with more terms. So maybe something like 2x squared times x squared minus 3x plus 7xy. Do something funky this time. And notice this is where the distributive property comes into play. Everything has to get multiplied by 2x. So we should get 2x to the 4th minus 6x cubed plus 14x cubed y. And we just keep that y there. Fits along with everything else. And so we're still using that same property of exponents where when we multiply like bases, we add the exponents. All right, so let's see. All right, so why don't you guys get to try another one of these? Try 4x to the 5th y times 6x squared plus 8xy minus 3y squared. And if you want, you can go ahead and type what you get in the chat if you'd like. So this is a new problem, but still in this scenario of a monomial times a polynomial with more than one term. So go ahead and try that one and see what you come up with. Go ahead and type it in the chat when you think you have the answer. And then we can compare. Okay, so I think looks like Jenna and Dakota, you both have it right. You just use a little bit different notation. Or do you? Yes, yes, it looks like both of you have the same answer. So I'll jot that down on mine too. So we're distributing the 4x to the 5th y. Megan, you're really close. Yeah, it's on the 6, Dakota. It's a shift 6. That's called a caret. So we're going to distribute and get 24x to the 7th y plus 32x to the 6th y squared. And you guys had that. And then minus 12x to the 5th y cubed. Okay, now bonus question on this one. They didn't ask us this, but what is the degree of this polynomial? You're very close, Jenna. You're very close, Samantha. Any other guesses out there? Here's a hint. Nope, it's not 24. Nope, it's not 5. Where'd you get 5, Dakota? I'm curious. So remember, the degree is essentially the number of variable factors that is the most in any one term. So if I look at the first term has degree 8 because it has 8 factors of variables. It has 7 x's and then 1 y. And then the second term is also happens to be degree 8. And the third term is also degree 8. It doesn't matter what order the terms are written in determining the degree. It's the highest of those 3 numbers. And since they're all the same, the whole thing has degree 8. So we don't add those numbers together. We just take the biggest of the 3 of them. In the previous problem, the degree would have been 4. Because the first term had degree 4, the second term had degree 3, and the third term had degree 4. So remember, there's a little 1 there that we don't usually write down. Does that clarify that for you a little bit, the degree question? So we sort of popped back to one of those. Good. All right, and I'm gonna cheat on that and just make sure I'm hitting all of these. Okay, we're not gonna do the one that they gave me next because they jumped all the way to something a little bit more difficult. So we're gonna pop to the next page, and this is still multiplying. And this is gonna be our case 3. And I'm gonna make this sort of a special little case. This is gonna be binomial times binomial. And it turns out we can still distribute, but you probably remember a way to sort of make sure that you get all of the terms when you distribute. Megan, the only thing from last week that's on YouTube is from last Monday, because remember, we didn't meet on Wednesday or Friday. So if you have specific questions you want answered, you can either email them to me or you can post them up in e-learning, or you can also take a look at some of the links to, say, Patrick JMT, who has some great videos on lots of things. Or if you give me a specific topic, I might even point you to one of his rather than making a new recording for you. Okay. So chapter 4 was the systems of linear equation stuff. Yeah. So if you're still struggling there, and remember on that material, you can also use your graphing calculator for the matrix material for the 3x3 systems, or you can use that matrix website that I posted. Okay. All right, so let's look at multiplying 2 binomials, and we'll make these first couple pretty nice. We'll just go like x plus 2 times 3x minus 7. Do you guys remember doing problems like these before? This is kind of a nice little chapter thrown in here because it's usually a little bit more familiar to everyone. So you get kind of a little bit of a break. So even though you might remember a little mnemonic for how to multiply this out, it is truly still the distributive property. And here's why. What we're going to do is, if we think of this whole thing, I'm just going to sort of group my x plus 2. If we think of that as one thing, then we distribute the whole thing. So we distribute the x plus 2. And you don't necessarily have to write this down, but I'm going to show you where your little shortcut that you remember probably comes from, or where it does come from. So I take my x plus 2 and I multiply it by 3x. And then I take my x plus 2. I'm going to actually use a plus. And I multiply it by -7. So I'm essentially distributing x plus 2. But then I have to distribute again because I notice, oh, I'm actually multiplying 3x by each of these terms. And I'm multiplying -7 by each of these terms. So if I write that out, I get x times 3x plus 2 times 3x. And I'm just being very careful to write down every single term. -7 times x and -7 times 2. So each of these get multiplied. 3x squared plus 6x minus 7x minus 14, or 3x squared minus x minus 14. And you probably remember a little shortcut name for this called foil, or the aluminum thing. You're supposed to laugh, right? My stupid joke. Okay, so foil was just a way to remember that you multiply together the first expressions, the outer, the inner, and then the last. So if I take a peek at this and go back to the original, I'll use blue, first, that was right there, first. Outer was minus 7x, so that was actually over here. Inner, it doesn't really matter what order we get these in as long as we get them all. And then last. And add them together, combine our like terms, and we're all set. Now, the nice thing about remembering that this is the distributive property is that when the problems get more complicated, like when we have a binomial times a trinomial, we don't make up a longer word like foil it or foil up or some other thing that has extra letters in it. What we do instead is we just remember the distributive property. So if we remember the distributive property, it doesn't matter how many terms we have, we can do any problem that involves multiplying. So let's try one with a binomial times a binomial. Oh, that doesn't get a number 4. It just gets a new example. Okay, so let's go 3x squared minus 7 times 3x squared plus 7. You guys try that one and go ahead and type it in the chat when you get your answer. Try to warm up my hands with my teacup. Oh my gosh, I almost spilled my tea. That would have been bad. Okay, so Jenna's got an answer up there. Give a couple more people a chance to. Okay, can you simplify that, Megan? Yeah. So you could do a little bit more work because your two middle terms were like terms and they happen to add up to 0 this time. So yeah, we've got our first, outer, inner, last. So 9x to the 4th plus 21x squared minus 21x squared minus 49. And so these two in the middle add up to a big 0. and we get 9x to the 4th minus 49. Okay, one more binomial times binomial just to see if everybody's paying close attention. Let's try, I kind of like that 3x squared minus 7. So I'm going to multiply it by itself. Another way to write this would be 3x minus 7 squared, right? Because squaring means multiply something by itself. So go ahead and do this one. It's probably easiest to use the first line, the way I gave the problem originally. But quite honestly, often they will give you the bottom line, and then you'll want to write it like that to make sure you don't miss something in your answer. So try that one and see what you come up with. Cleaning my office while you guys work on that one. Okay, Jenna, I think I agree. Does anybody else get what Jenna gets? Dakota agrees. Plus not equal. Oh, okay, Corin, thank you. And Megan agrees too. Good. Dakota, looks like you fixed it. Do you see what you did wrong the first time, Dakota? So a quick note. Yeah, they're not going to cancel because they both have the same sign. So we have a 9x to the 4th, and then minus 21x squared, and then minus another 21x squared, and then plus 49. So we have the same 4 terms as before, except for the signs. And then when we add things together, we get 9x to the 4th minus 42x squared plus 49. Yeah, a sign mix up. I will show you a nice little way to sort of remember those last two. Sort of those are a couple of special products that come up quite often, so they're going to be worth remembering. So we'll put those in next. But let's add another page and let's try this time. So this is number 4. This one's going to be anything times anything. So any kind of polynomial times any kind of polynomial. And I guess, you know, I could go 5 terms times 7 terms, but you'll kind of get the point with less than that. So let's try specifically, let's try a binomial times a trinomial. So 2 terms times 3 terms. And you guys all know what 2 times 3 is, right? 2 times 3 is 6. Okay, so 2 terms times 3 terms, we're going to have 6 terms to find. If we had 3 terms by 5 terms, we would have 15 terms to find. You can see why I'm not going to give you 3 terms times 5 terms. It doesn't really show me too much other than that you're paying close attention and being very careful, but I'm not trying to trip you up with 15 terms. So let's try, this is one that came from Alta. So they did m minus 7 times 5m squared plus m minus 5. And the way we do this is the same as before. So that's why remembering the distributive property is going to be good for us. We're going to distribute our m and write down all of our terms. And then we're going to distribute our minus 7 and write down all of our terms and add them together. So let's see if we can do this. M times 5m squared is 5m cubed. M times m is m squared. And m times negative 5 is minus 5m. Then I get minus negative 7 times 5m squared is minus 35m squared. And it's not necessary to write that on a separate line. I just like to line up the things that I notice are alike. And then minus 7 times m, minus 7m. And negative 7 times negative 5 is positive 35. So in doing it this way, I can just add together my like terms that are lined up. Minus 34m squared minus 12m plus 35. And we're good. So notice we had 6 terms at this step. But when we added our like terms together, we only ended up with 4 terms in our final answer. All right, so let's see. You guys can try another one. So let's try c plus 7 times 5c squared minus 5c plus 5. So you guys try that one. Pop it into the chat when you think you've got the answer, and then we'll compare. Okay, Jen, I have to check in my head. I don't want to write the answer down yet because I don't want to show everybody. But there's good news. Oops, you and Dakota don't quite agree. 5c cubed, yep. That's the first term. Jenna and Dakota are close with their answers. One of them is correct. I'm not telling yet, Dakota. Good question. Go back and check your work and make sure all your signs are correct. Okay, so Corin agrees with Jenna. Megan agrees with them. Dakota, you're getting outvoted. I think you have a sign error on your second term, Dakota. So I get a 5c cubed. Let's see, we'll do 1, 2, 3. I should just even, I could even write these in red. Minus 5c squared plus 5c. And then I get these guys. So I get plus 35c squared minus 35c plus 35. So when I add those together, 5c cubed plus 30c squared, because the positive 35 is the larger in absolute value, minus 30c plus 35. Do you see where you have that sign error in your second term, Dakota? Okay, good. So that's multiplying. Not really too horrible. Just keeping in mind the distributive property and then watching your signs, and you should be in good shape. Okay, so let's see. Let's do another page. And this one's going to be so. And we're going to split this into actually, yeah, three categories as well. So the first one's going to be a monomial divided by a monomial. And we need this one in order to do the rest. So this is kind of our building block. So one term, I might have something like 24x to the 7th divided by one term, 3x squared. And this is really just a property of exponents problem and dividing the coefficients. So we're going to do 24 divided by 3, that's 8. And since the x to the 7th is 7 factors of x in the top and 2 factors of x in the bottom, we can cancel 2 of them, leaving us with 5. Or if you remember the property of exponents, we subtract the exponents. So 8x to the 5th. And we're using the property, x to the m over x to the n equals x to the m minus n power. And it's the top exponent minus the bottom exponent. Now notice that that means that sometimes you could end up with negative exponents. So we're going to define negative exponents for our use so that it makes sense along with this property of exponents. Oh, cool, Jenna. Groceries are nice. Now you can have lunch. All right, so let's try another one. Let's try, oh, got really thick. Let's try that again. Let's try 10 x squared divided by 25 x cubed. So go ahead and give that one a try. Slightly sneakier than the last one because we don't get a whole number. So let's, okay, so Corin, I think you're saying 2/5. I'm gonna write down what you said here. 2/5, that's the 10/25 reduced, so that looks good. And then you said x to the minus 1 power. And that's correct. Now, most of the time, they're gonna tell you to write your answers with only positive exponents. So we're gonna convert that to 2 over 5x. We're going to leave that x in the bottom with a positive exponent. By the way, this one is not a polynomial because polynomials need to have only positive powers of x or constants. So that one's not a polynomial. Everything else we've seen so far is. So when we divide two polynomials, we might not get a polynomial for our answer. We might get something that's no longer a polynomial. Notice what this is saying is that x to the minus 1 means 1 over x. And similarly, if we had x to the minus 2, that would mean 1 over x squared. And generally, x to the minus n means 1 over x to the n. So that's how we define negative exponents. We also, because let me give you a quick division problem that you should be able to get very fast the answer to. Oh, Megan says, why is the x to the power of -1? Well, no, that's okay. I think Corin used our property of subtracting exponents, and she did so correctly. So she subtracted 2 minus 3. And when we subtract 2 minus 3, we get -1. But notice that another way that she could have looked at this would have been to say, well, in the top, I have 2 x's, and in the bottom, I have 3 x's. So in pairs, 2 of the pairs cancel, leaving me with a 1 over x. So that's where we get this definition that x to the minus 1 means 1 over x. That was a good question though, Megan, because it's going to keep coming up and we're going to have to be able to sort of convert back and forth on those things. They will almost always ask you for answers with only positive exponents. So when you do get an x to the minus 1 power, you want to go ahead and write it this way with an x to the positive 1 down in the denominator. So that -1 power is actually just telling us to take the reciprocal. So if you've got a calculator handy, try this on a calculator, 2 to the minus 1 power. Or you could even just go type it into Google if you want to do that on your phone or on a computer or whatever. And what you should see come up on the calculator is probably 0.5, depending on what calculator you're using. You might see 1/2. Either way, it fits our definition because 2 to the minus 1 means 1 over whatever that was, 1 over 2. In other words, the negative exponent is telling us to take a reciprocal. It's telling us to flip that fraction. Let's try another one. How about 2 to the minus 3rd power? If you've got a calculator, you can do this on the calculator and then probably change it back into a fraction, but let's try to use our definition. This says 1 over 2 to the third power. And now I'm going to do 2 times 2 times 2. That's 8. This is 1 over 8. If you did that on a calculator, you should have gotten 0.125. So we sneaked in a little info dealing with negative exponents here. Probably do a little bit more with those, although I might hold off on a ton more on those for next time. All right, so type number 2. This is going to be polynomial. So I'm going to have more than one term in the top divided by a monomial. So one term in the bottom, but possibly as many terms as I want in the top. So I might see something like 5x squared minus 15x plus 10 divided by, oh, let's do 5x. And the way I like to do these is to sort of think of it as, well, everything has to get divided by 5x. So I'm just going to write it out where everything gets divided by the 5x separately. And then I really just have 3 little problems. Oops, there's no x there. I have 3 little problems like we had on the previous example. So monomial divided by monomial, and I can use my properties of exponents. And I can cancel some 5s. 5 divides into 5 once, 5 divides into 15 3 times, 5 divides into 10 twice. So now I'm going to go over and look at my x's. X squared divided by x is x. X divided by x is 1, so that's just a 3. Notice these guys canceled. And then my last term, I'm just stuck with 2 divided by x. Or if you like negative exponents, you could have said 2x to the minus 1 power again. So this is just kind of extending that monomial over monomial to more terms. Let's try another one. How about 24x cubed y plus 12x squared y squared minus 18xy squared, sure, divided by 6xy. So let's see what you guys get when you divide that out. I'll write the first step out for you, and then you can just type your answers into chat if you want. So I'm going to divide each term by 6xy. And then you need to simplify each term, so see what you come up with. Jenna, check your division. Check your numbers. Your X's and Y's look okay. Right, Samantha, that first term's supposed to be a 4. And Jenna knew that. I think she just typed it wrong. So 4x squared plus 2xy minus 3y. Yeah. So just either a division error or she just typed the wrong number there. I think she typed the wrong number because she got 18 over 6 is 3 in the last term. So I'm going with that. All right, so those aren't too bad, those first two groups. The third group is going to kind of put both of those pieces together, and these usually take a little bit longer. So we'll call this number 3. So this is going to be polynomial. And we could do divided by any size polynomial. We're going to do our example divided by a binomial. So you might get a problem that looks like this. It might say something like 6x squared minus 3x plus 2. And they might even write it with just the division symbol divided by x minus, let's go x minus 3. So remember what we're trying to do when we're doing a division problem. We're trying to figure out what we could multiply by x minus 3 to get 6x squared minus 3x plus 2. And we might have some stuff left over. So I'm going to take you back a few years, back to your youth. And you guys, I know, will remember doing this. You might not remember liking it because you might not have cared for it very much. But when you first did division and you had problems like 10 divided by 5, you said, oh, okay, well, I know that that's 2. And you knew that because 2 times 5 is 10. Then they started getting a little trickier and they said, okay, well, what's 12 divided by 5? And you're not allowed to use fractions and you're not allowed to use decimals in your answer. So you set this up and you said, well, if I do 12 divided by 5, who remembers writing division problems this way? Probably not so much with these. Megan does. But you said, okay, well, 5 won't go into 1, so I'm going to go out a little further. 5 will divide into 12 2 times. This is really just an estimation. And then you multiplied, and you said, okay, well, 2 times 5 is 10. And then what did we do with the 12 and the 10 next? 5th grade was the last time, Corin. That's about right. Yep, somewhere around 5th grade. We subtract. So we go 12 minus 10 is 2. Now, if you were working with decimals, you could make this a 12.0 and keep going. But with polynomials, it's not going to make sense to have decimal polynomials. So we're not going to do that. We're going to write our answer in one of 2 ways. And I'll write the 2 ways here. So we could write our answer using this thing, which is the remainder. So the answer, the quotient is 2 with a remainder of 2. You guys remember writing that? Yep, Megan does. Make it a remainder. The other way you could write it would be to say 2 and 2/5. That's the remainder over the divisor. Now, keep in mind, we are going to have expressions that are polynomials to work with. So that denominator, that divisor, is going to be the x minus 3 in our current problem. All right, so now I got to make sure I give you the same problem. So it was 6x squared minus 3x plus 2. So I'm going to do a new page. 6x squared minus 3x plus 2. And we're dividing by x minus 3. Did I keep that problem the same? I hope I did. Okay, so this is a little bit trickier. We're going to start with this estimation. And the estimation step is that dividing two monomial steps. So we're going to start with first term and first term. And we're just going to come up with an estimation. So I'm going to go off to the side here to do my estimation. 6x squared divided by x. And we just worked on these. That is 6x. And just like before, I'm going to write my answer up on the top, and then I'm going to multiply. So this is the estimate step. Then I'm going to multiply. And I like to line up my terms. Some people like to put that 6x above the 6x squared. It doesn't really matter as long as it's up there somewhere. So what am I multiplying? I'm multiplying 6x by x minus 3. So now I'm back to my distributive property, 6x squared minus 18x. And I'm going to line that up right below here, 6x squared minus 18x. And the next step is the subtraction step. Remember when we subtracted polynomials and all of the signs on the polynomial that were getting subtracted changed? Probably the best way to do this is instead of subtracting, you can change signs and add. It's going to make our life a lot simpler. So if you're writing on a piece of paper right now and you're using pencil, grab an ink pen and even preferably a red ink pen or something that it shows up really nicely. I'm going to switch colors to red. I'm going to change the signs and I'm going to add now. So notice this is 0. If that first term isn't 0, you did something wrong. Because our goal was to get past that 6x squared term. Now I've got 15x. Remember, I changed the sign and I'm adding negative 3x minus negative 18x is plus 18x. And now bring down the next term. And then repeat the whole process again. So I'm going to bring down my 2. And then I'm going to go through this process of estimate 15x divided by x is 15. I'm going to multiply 15 times x minus 3 is 15x minus 45. And then finally, I'm going to subtract, and I'm going to change my signs and add again. So minus plus 47. Once I have less x's in my remainder than I had in whatever I was dividing by, I'm done dividing, and I'm down to my remainder. So this thing is my remainder. And I could write my answer as 6x plus 15 with a remainder of 47. Or I could write my answer as 6x plus 15 plus 47 over whatever I was dividing by, my divisor, x minus 3. So those are two different ways that I can write the answer. They mean the same thing. If I want to check this problem, I would multiply my quotient, 6x plus 15, by x minus 3. And then I'll add back in my remainder. So let's just multiply this out first. Megan, I saw your question. I will answer that in just a second. So 6x squared minus 18x plus 15x minus 45, or 6x squared minus 3x minus 45. And that's not my original expression, but when I add in that 47, I'm going to get the 2 that I started with, because those two add up to 2. So it checks. Perfect. Okay, Megan asked, what would the homework accept? So what we're going to do is we're going to go find one, and we're going to see exactly what they do. There could actually be 2 different kinds of problems. So they might just ask you like what the remainder is, or they might ask you to write it in the form where you see it as a fraction. So I am going to stop my share. Yeah, I'm going to stop my share from my iPad and go back over here. Oops, but I need to say I'm sharing here. However, not yet. So let me get out of the multiplying section and get into the dividing section. Special products. Yeah, we'll talk about those. I might save those for next time. Dividing and preview. Hopefully I don't have to cheat through too many of these. So, okay, here we are. So this was one I did an instructor cheat on that one. Oh, good. They gave me one already. Use polynomial long division. So just so we can see what they're expecting on this, we're just going to hit instructor cheat. Then we can answer Megan's question. So notice they are expecting you to write your answer as a fraction. So the remainder was 1023, and they're writing the final answer as something plus 1023 over m minus 7. So you see that, Megan? You're welcome. So we know what they want in terms of how to write that remainder in your answer. Okay, that is, now that we cheated on one, we're going to just continue until we get another one for you guys to try. Oh, this is a fun one. This is a really fun one. You guys write this one down, but there's a little glitch on it. So write the problem down really quickly right now, and I'm going to leave it up so I can come back here, but I'm going to switch the share to my iPad. So I can show you something interesting about this. So the problem says, and I think this will be a good place to stop. The problem says y cubed minus 1 divided by, oops, I did not really mean to make those circles. They just came out that way, y plus 4. So it's very similar to the last problem, but that y cubed minus 1 looks a lot simpler. So here's the thing. We're dividing by y plus 4. Think about if you were dividing by a number like 1004. You would put 2 zeros in. You would write 1004. You would have zeros in as placeholders for the hundreds and the tens places. We need to do the same thing here. We're going to write y cubed, but we're going to put a placeholder in for the y squared, and we're going to put a placeholder in for the y, and then we're going to put our -1. Because we might end up with a y squared or a y cubed in our result, and we'll need to have a place where we're subtracting it. So we always want to put placeholders in underneath the division bar in the dividend. You don't need placeholders out here to the left. Out to the left on the y plus 4, there aren't any missing terms anyway, but even if there were, that's just so we can remember what we're dividing by. We don't write anything else over there anyway. So these placeholders with 0 coefficients will help us keep everything in track, on track to the right answer. So we're starting with y cubed divided by y. And what do we get? We get y squared. So we're going to line that up, y squared, and then we're going to multiply. Y squared times y plus 4 is y cubed plus 4y squared. So again, lining everything up, y cubed plus 4y squared. And then we're going to change signs and add. So that becomes a minus, that becomes a minus. That's a 0, which is good. And we have minus 4y squared plus our 0y. So we just bring down that 0 term. And then we do the whole thing again. Minus 4y squared divided by y. So we're only dividing first term by first term. We get minus 4y. Goes up here. And then we're going to subtract minus 4y, or multiply rather, times y plus 4, minus 4y squared minus 16y, goes here. And I really do recommend when you're doing these on paper, use 2 colors. So, have a blue and a red, or a pencil and a blue or red pen so you can see the difference. A pencil and a black pen doesn't work very well because it's hard to tell, to have the difference in the color jump out at you. But if we change our signs now, we can see what we did. We got a 16y minus 1. One more time, and then we'll be done. This one was a little longer than the last one. 16y divided by y is 16. So plus 16. And then multiply 16, oops, I'm out of room, 16 times y plus 4. I'll just write it here, 16y plus 64. And change our signs again. -1 plus -64 is -65, and that's our remainder. So using the same method they did last time to write our answer, it would be y squared minus 4y plus 16 minus 65 over y plus 4. Boom. So you can kind of see these could get long, right? I don't think they should give you anything more than, say, a 4th degree divided by something. We can check it and make sure we got it right. Let's switch the screen share back to that. Yes, that's what we had. Okay, so the long division ones are probably the problems that are going to give you the most trouble. Notice that they also might give you problems in function notation, but you would still do them the same way. Okay, so how are you guys on that for today? It gave you some more things to think about. All right, next time I will pop back and do a little bit more on negative exponents and scientific notation, and then any other questions you guys have. Okay? We good? You're welcome, Corin, no problem. All right, everybody have a great day. I will see you Wednesday noonish, maybe a little bit before, but I'll be around. And if you have questions in between, just give me a shout out and let me know.